This is Chapter 10, Lesson 3 on polar. The first lesson that we will see here is basically a review of stuff that you should know. So in addition to that, please, if you have the notes available from online, you can follow through from that. Okay, let's start off. So number 1 for polar calculus. So ordered pairs are given in the form r comma theta. R is a distance from the origin, and theta is angle revolving from the x-axis counterclockwise towards the y-axis. So number 1, we're taking points that are in polar form and we are graphing them. So first, A, we have 2 comma pi over 3. So I'm going to draw a small Cartesian plane, and we can think of going out from the origin 2 units because the radius of 2, and then revolving this pi over 3 units. That leaves us to this point here. So, or we can think revolve pi over 3 units and then go out pi over 3 radians and go out 2 units. That makes the point there. B. The next thing we're going to graph is -3 comma pi. There are a couple ways to think about this. We can think about going 1, 2, 3 out, rotating pi radians, and then because of the negative, going backwards, or the opposite of the distance, which is here, this point. The other way to think of it is to start at -1, 2, 3, and then rotate pi from there, and that brings us to the same point, C. Okay, in C we have r equals 2. So this says no matter what theta is, no matter what the angle is, r is always going to equal 2. So that's going to show up as a circle of radius 2. Horrible circle, but you get the idea. So for every theta, r is 2. D, this one is theta equals pi over 4. To graph this one, no matter what r is, theta will be pi over 4. So we go over pi over 4 and go out 1 unit. Pi over 4 go out 2 units, 3 units, -1, -3. And it makes the line y equals x. Okay, finally, for part E. This one we're going to graph a function. This is r equals 2 plus 2 cosine theta. So the independent variable here is theta, and for different values of theta, r will change. So what we're going to do is construct a chart, values of theta and values of the function r. And we're going to go 0 for theta, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi ... So when theta equals 0, you plug it into the formula, and r comes out to be 4. Then it comes out to be 2 plus radical 3, 2 plus radical 2. At pi over 3, it comes out to be 3. Pi over 2, 2, 1. 2 minus radical 2, 2 minus radical 3, and then for pi, it equals 0, ... It might be helpful to have the decimal approximation, so 3.7, 3.4, over here we have 0.6 and 0.3. Now we're going to take a moment and we're going to graph this. It's a little bit tricky on this format to graph, but I'm going to try my best. So there's the Cartesian plane. When theta equals 0, the radius is 4. For theta is pi over 6. The distance is going to be 3.7. For pi over 4, the distance is going to be 3.4. Pi over 3, the distance is going to be 3, and then at pi over 2, the distance is 2. 1, 2. All right, keep going. 2 pi over 3, the distance is 1. 3 pi over 4, the distance is 0.6. And then 0.3. And then finally at pi, it's at the origin, or the pole, as we call it when referring to polar calculus or polar curves. So connecting these points carefully. Boy, is that ugly. But this is only half the shape. You can see that this is 4, and then it ends at 0, so it's not fully connected. We would actually have to go all the way out to 2 pi for this to be fully connected. And if I draw the other portion, it looks like this very distorted and disturbed heart, otherwise known as a cardioid. And you may remember that from a previous course. And we're going to come back to this exact equation quite a few times in this lesson, including the next video. So please know it, the cardioid. In example 2, we take some polar points, r, theta, and we convert them into Cartesian or rectangular points. In order to do that, we want to come up with a relationship between r, theta, x, and y. So on a set of axes, let's consider a point out here. Okay, so that particular point has an x coordinate, it has a y coordinate. The distance from the origin to the point is what we call r, and rotating in this fashion, counterclockwise, is the angle theta. That makes a right triangle. So if I look at this right triangle, let's label this again theta, r, x, and y. And from this we can see that the cosine of theta is equal to x over r, and the sine of theta is equal to y over r. So that tells me that x is going to equal r times the cosine of theta, and y is going to equal r times the sine of theta. Another important property of this is, using Pythagorean Theorem, that x squared plus y squared is equal to r squared. So let's take a look at the examples. 2a, we want to go from radical 2 pi over 4, that's our r theta, and we want to again convert that to the xy point. So in order to do that, we're going to say x is equal to r, in this case radical 2, times the cosine of the theta, the pi over 4, and that's going to simplify to be 1. The y is going to be radical 2 times the sine of theta, again is 1. So this point converts to 1, 1 in Cartesian. Let's take a look at 2b, or not 2b. 1, 0 is the Cartesian point, is the polar point. Let's graph that for a second. So if I go out a distance 0 to 1 and rotate 0 radians, well, that's going to give me this point here. So this is 1, 0 for polar point, but it's also 1, 0 Cartesian point. Let's prove it. X equals r, which is 1, times the cosine of theta, which is 0, and that's 1. And y is 1 times the sine of 0, which is 0. 1, 0. Finally, our last point, negative 3, 5 pi over 6. So we have x is negative 3 cosine 5 pi over 6, which is 3 radical 3 over 2. And our y is going to equal negative 3 sine of 5 pi over 6. And that comes out to be negative 3/2. And that is our Cartesian point. That is our rectangular coordinate of the point. There it is. In example 3, we're taking equations that are in polar form and converting them into Cartesian form equations, ones that we recognize easily with x and y. So here we go. R sine theta equals 0. We should recognize r sine theta is y. So y equals 0 is the equation. horizontal line, the x-axis. Next one, well, r is 4 over sine theta, which says that r sine theta equals 4, or simply y equals 4. Part C, gosh, if you can read that, r cosine theta plus r sine theta, so we recognize as x plus y equals 1, a line. Okay, very important, please get in the habit of not dividing by r. So don't think, oh, I'm going to divide r by both sides. In fact, I don't know why you'd even think that to begin with, because we see r squared, and we know that that's x squared plus y squared, and the right-hand side is 4 times y. And also, interesting to note what this might graph as. It's a circle. We would complete the square, so x squared plus y squared minus 4y equals 0, and then after completing the square, we have x squared plus quantity y minus 2 squared equals 4, which is a circle centered at 0, 2, and a radius of 2. Okay, moving down to E, where we have r squared times the sine of 2 theta equals 2. Okay, so I'm going to employ an identity. So r squared, and then the sine of 2 theta is 2 sine theta cosine theta equals 2. Divide everything by 2, and then we're going to distribute, or rather separate the r squared as r times r, and apply 1 to the sine and 1 to the cosine. So that gives us r sine theta times r cosine theta, or y times x equals 1, which is a rational function or hyperbola. Okay, f. Okay, now in f, class, you would take a little bit of time, but right now I'm going to spoil it and say you're going to multiply both sides by r. So r squared equals r times a sine theta. X squared plus y squared equals a y, and that looks like this one here, so it's also a circle. Okay, last one is G. R equals cotan theta, cosecant theta, and several ways to do this, but R equals, well, we recognize cotangent as cosine theta over sine theta. Cosecant is 1 over sine theta. If we multiply that to both sides, we have r sine squared theta equals cosine theta. Multiply both sides by r. Now there is a temptation here to say that this is x squared plus y squared, but then that leaves us with this. So we're going to apply the r squared as r and r to both the signs that are present. So this is actually going to be y squared equals x, which graphs as a sideways parabola. That's the end of part 1, the review of polar coordinates, polar graphing, converting, and the next video we will actually do some calculus. The end.